of scary when you see that we're going to do 3 sections today. We didn't even finish 1 section Monday, but today we're going to do 3 sections, R4, R6, and R8. That's because I'm just going to give you little pieces of them. Just remind you of some things that I'm pretty darn sure you already know, and then we'll get to a few things you may have forgotten, and we'll refresh on those. R.4 is just everything you need to know about polynomials, and you know how to access the ebook if you need to read this section, right? In my math lab, you can access the ebook. If you do, you'll see the definition of a polynomial. It's just a sum of terms. The terms are a number times a variable to an exponent. The only restriction on the exponent is it has to be non-negative and a whole number. So what that means, polynomials don't have negative exponents, and polynomials don't have x's in the denominator, because how do x's get in the denominator? What makes x's go to the denominator?
If there's a negative exponent.
And we just said we can't have negative exponents, so we can't have variables in the denominator. Other things are polynomials. If it's a sum of terms, number times x to a power, as long as the power is non-negative and not a fraction, then it's a polynomial. In R.4, we're going to add, subtract, multiply polynomials. R.6 will divide polynomials. Adding and subtracting polynomials is just combining like terms. Now, when each of my children was born, the doctor laid her in my arms, and I said, here's what I want you to know about life. X plus x is 2x. X times x is x squared. Get it straight. I don't want you to still be confused about that when you're 3. When you're adding like terms, you just add the coefficients. So 3x plus 2x is what? 5x. All right. When you're adding polynomials, you just combine like terms. All the terms that have the same exponents can be combined into one term. I'm not going to do an example because we have so much to do, and I know this is probably boring you anyway. I'm not going to do an example of adding polynomials, but I want to show you something to be careful of when you're subtracting polynomials. There's a most common mistake that I can illustrate with this problem. What does it mean when you have a number outside stuff in parentheses? What do you do with that number? That means multiply, or I think somebody even said the big algebra word, what's the distribute? You distribute the 2, which means multiply. So whatever is immediately in front of that parentheses, that's multiplication. On number 32, what is in front of the first parentheses, other than the problem number? Just 1. And distributing on 1 doesn't do anything. I can just copy that down without parentheses, and it would be the same thing. What is immediately preceding the second parentheses? And that does do something. Multiplying something by -1 changes the sign of everything inside parentheses. I don't want you to think hocus pocus, change all the signs, because nothing in math is hocus pocus. But I want you to think I'm multiplying each term inside that parentheses by -1, and multiplying by -1 has the effect of changing the signs. So I could rewrite that problem as x squared minus 3x minus 4, because the +1 in front of the first parentheses doesn't do anything. And then distribute that -1 through the second parentheses, and I'll have -x cubed plus 3x squared minus x minus 5. And again, not hocus pocus, but because you're distributing a -1. And then you look for your like terms. Any like terms you have can be combined. And we usually write the answer in descending order. The power is going down. So the highest power I have is -x cubed. What's x squared plus 3x squared? 4x squared, because the coefficient of that first x squared is understood to be 1, and you're just combining the coefficients. 1x squared plus 3x squared is 4x squared. What would give me x to the 4th? If I accidentally wrote x to the 4th, what would I be thinking of instead of hey, I'm adding here. Multiplying would give you x to the fourth, but we're not multiplying. We're just combining like terms. So 4x squared, and then I have a negative 3x minus x. What's that? Negative 4x, because the coefficient of this negative x is negative 1x. You don't have to write the negative 1, but if it helps you, you can. Negative 3x minus 1x is negative 4x. And then my constants, negative 4 minus 5 is negative 9. And then just double check to see if I did anything stupid. Negative x cubed plus 4x squared minus 4x minus 9. I think that's right. The number one mistake on that problem is just going in the parentheses and changing all the signs in the original problem, and then it all gets so messy you can't read it anymore. And so I'm giving you just a big tip when I say, anytime I look at your paper, I should be able to see the original problem, not written on. And then whatever you do after that, go down the page, making sure every line is equivalent to the line above it. If you're going over pre-calculus and calculus, what you call silly mistakes, you got to learn not to make them, because in pre-calculus and calculus, your bridge will fall in. The way to stop making silly mistakes is to work down the page and then go, is this equivalent to this? Is this equivalent to that? Could I go backwards and get to the original problem? Yes, I can. All right, multiplying polynomials. We've got two great examples in the book, examples 7 and 8 on page 43. Near that, page 44 or so, there's a box that says special product formulas. My brain, I feel, is just almost that capacity. Not that I'm that smart, but my brain capacity is that small. I'm just getting full. That's why I'm having trouble with names. I don't want to memorize formulas that I have some other way of figuring out. It's because if I memorize stuff that doesn't make sense to me, I forget it. So I don't need a special product formula to multiply 3x plus 2 times 3x minus 2. What's that word that comes to my head whenever I see a binomial times a binomial? It's a 4-letter word that starts with F.
Foil.
And it's full. It's full no matter what you thought. Full is multiply the first, and then the outer, and then the inner, and then the last. That works just as well on this problem. I don't have to have some special product formula memorized. I'm just going to multiply the first and get what? Well, make sure you're multiplying 3x times 3x is 9x squared. Yeah, don't forget to multiply the 3's. And then the outer terms are the two that are farthest from each other. What's 3x times negative 2? Y'all talk loud. Negative 6x for the outer. Inner is the 2 times 3x is positive 6x. And last is the last term of each binomial. Positive 2 times negative 2 is negative 4. When I combine like terms there, those middle terms are going to give me 0, and I'm just going to be left with 9x squared minus 4. Usually when I multiply a binomial times a binomial, most of the time I get a trinomial, 3 terms. How could I have anticipated by looking at this original problem that, hey, I'm not going to have a middle term here?
They're the same thing with the minus.
They're identical factors, except for one has a plus, one has a minus. Anytime that happens, you don't even have to write down all 4 steps of FOIL if you don't want to, because if they're identical, except for one has a plus, one has a minus, the middle terms are going to give you 0. And really, that's all the special product formula is trying to get you to see. You don't want to memorize x minus y times x plus y is x squared minus y squared, when you can just remember, hey, if I FOIL these two, the middle terms are going to cancel. Give me 0. There's a most common mistake on 86. I'm all about showing you the most common mistakes because they kind of make sense. A lot of people do it, but you got to be careful. When you have a binomial squared, what does it mean to square something? Just multiply it by itself. That's what squaring means. So if I have 2x plus 3y squared, that means 2x plus 3y times 2x plus 3y. That's the definition of what it means to square something. I've seen folks who write down 2x plus y times 2x. Let me try again. I've seen folks write 2x plus 3y times 2x minus 3y, but that's not what squaring means. If you write this down correctly and then FOIL it, you'll get the right answer without memorizing a formula. First would give you what? 4x squared. Outer would give you what? 6xy. Inner would give you, what's that? I think I heard 4 different things. 6xy. And last would give you 9y squared. When you combine like terms in the middle, what do you get? 12xy, and if you were working in the tutor center and some angry student came in and said, why isn't that 12x squared y squared? What are they thinking instead of addition? They're thinking of multiplying, all right? When you add, you just combine like terms, you just add the coefficients. So that's 12xy plus 9y squared. Remind me of this. How could I look at 70 and 86 and know that this answer is going to be a binomial and this answer is going to be a trinomial? How can I tell that just by looking?
The plus and the minus.
This is plus times minus, but you're going to cancel each other out when you combine them. This is plus times plus. It's not going to cancel out. All right. R.4, you only have a few problems in the homework from R.4 because it's way long time ago, 8th grade algebra. It's just combining like terms and multiplying polynomials. Division doesn't hit until R.6. So let's talk about division for a second. If I had to teach you long division, we couldn't cover 3 sections in one day. Long division takes practice, but I do want you to understand that it's the very same steps that you use in, I don't remember what grade you learned long division, 5th grade or so, when you divide, and we're not going to do this whole problem, but when you divide 32 into, let's say, 7,584, when you learn to do that, you learn a process of you divide 32 into 758. Whatever you put on top, then you multiply that times 32. Then you subtract, you bring down the next digit, and you start all over again. That's the steps for long division. Divide, multiply, subtract, bring down, repeat. It's the same thing with polynomial long division, only it's uglier because it has x's in it. Everything's uglier when you have x's in it. Unless you just love x's, and then you can call it prettier. Everything's prettier when it has x's in it. This example, divide 2x to the 4th minus x cubed minus 7x squared minus 3x plus 10 by x minus 2. If I was going to do this the same way I did in 5th grade or so with just numbers, I would put the x minus 2 out in front of that symbol, put the dividend under the symbol, and then start by going x goes into 2x cubed 2x, said it wrong. X goes into 2x to the fourth, 2x cubed times, and then multiply 2x cubed times both of those terms, and then subtract. And then bring down, and then divide again, and then multiply, then subtract, then bring down, and then divide again. The process is the same, it's just uglier, and we really don't have time to do that. And you'll not be glad we don't have time to do that. There are special circumstances in which you can use a shortcut, and the shortcut is called synthetic division, and it's fabulous. You can't always use synthetic division, but when you can use synthetic division, it becomes your best friend. Now let me tell you when you can use synthetic division. Right here, this first note. You can only use synthetic division when you're dividing by plain old x plus or minus a constant. If that was x squared plus 7, I couldn't use synthetic division. If it was 5x plus 7, I couldn't use synthetic division. But because of what our needs are going to be later in the semester, I'm only going to give you problems in tonight's homework that you can use synthetic division so that you don't have to do this. We're not going to really need this later this semester. We are going to need this. So you can only use synthetic division when you're dividing by plain old 1x to the first plus or minus a constant. And before you begin synthetic division, you have to see if you're missing any terms. What I mean by missing any terms, this dividend has 4th degree, 3rd degree, 2nd degree, 1st degree constant. And so when I do my division, all my like terms line up very pretty. If I was going to do this by synthetic division, and let's say I was missing an x cubed, if I don't notice I'm missing a term, and if I don't put a 0 in its place, my like terms don't line up when I do long division. Similarly, I'm not going to get the right answer if I don't notice that there are missing terms and put zeros in when I'm using synthetic division. This one's not missing any terms, so let me just do this example to show you how much faster synthetic division is than long division. It's the same problem, we're going to get the same answer, but we're going to do it a different way. Here's how synthetic division works. If you're dividing by x minus 2, you put the opposite of that negative 2 in a box. And changing that one sign that one time takes the place of, in long division, every time I divide and multiply, I have to change the signs in order to subtract. In long division, I'm changing the signs here and here and here and here. In synthetic division, I only change that sign one time, and that takes care of all the sign changing. So if you're dividing by x minus 2, you put a positive 2 in that little box. Out beside that box, you put the coefficients, of the dividend, the thing that you're dividing into. And I have to zoom out just a little bit so you can see both of them at once, but then I'll zoom back in so it'll be bigger for you. The coefficients of the dividend are 2, -1, -7, -3, +10. So that's what goes on the line beside the box. After that, synthetic division is just a process of multiply, add, multiply, add, multiply, add, till you run out of stuff to multiply and add. You bring this first coefficient straight down under that horizontal line. This is going to seem like magic for a minute until you see that we get the same answer. It's not magic, it's just a shortcut. You always bring that first coefficient straight down, and then you start the process of multiply what's in the box times what's on the bottom row. This 2 times that 2 is 4. it goes under your next coefficient. And then add -1 plus 4 is 3. You multiply what's in the box times what's on the bottom row. 2 times 3 is 6. Put that under the next coefficient and then add. You get -1. You multiply what's in the box times what's on the bottom row. 2 times -1 is -2. Put that under your next coefficient and then add. And then one more time, what's in the box times what's on the bottom row. 2 times -5 is -10. And then add. That gives you 0. Now, how can that, why did I say we would get the same answer? Obviously, that's not the same answer as we got right here. But what do you notice about these numbers and those numbers? What we have is the coefficients of the answer. Here's the 2, here's the 3, here's the -1, here's the -5. We just have to put the x's back on there. If I'm dividing an x to the 4th by an x to the 1st, what power is my answer going to start out with? Yeah, x to the 4th divided by x to the 1st is x cubed. So this 2 is the coefficient of my x cubed. And after that, my powers just descend. That 3 must be the coefficient of my x squared. That -1 must be the coefficient of x, and I don't have to write the 1. If that's my x to the 1st, then that -5 is just my constant. Guess what that last number always is? Remainder. This one didn't have a remainder. It had 0 remainder. X minus 2 went into that big ugly polynomial evenly this many times. So if I don't have a remainder, I don't have to write plus 0 on the end. That's my answer. And it's the same answer I got over there. So which method do you like the best? We'll stick with long division just to prove we're tough? No, we're tough, but we're not sadists. We don't hurt ourselves unnecessarily. If this will work on every problem, synthetic division is what I'm going to use. It won't work on every problem, but it will work on every problem that you're just dividing by x plus or minus a constant. And since that's really all we're going to use later in the semester, and because we have so much to talk about, all the ones in the homework you can do by synthetic division. We're going to do another one because just one is not enough examples for anybody. But before we do a different one, do you have any questions about, hey, I don't get why you said something right there? Any questions? All right. If we had time, if we had more time, we could check our answer. Let me just show you this real quickly. If I say 5 goes into 12 2 times with a remainder of 2, how do you check that?
2 times 5 plus 2.
You multiply 2 times 5, and then you add the 2, and sure enough, you get back the 12. You check the answer in algebra the same way. It's just uglier. You multiply the divisor by the answer. The answer to a division problem is called a quotient. You multiply the divisor times the quotient. If there was a remainder, we'd have to add it back on, and then we'd get the dividend we started with. So it's checkable. Make sure you remember those 2 notes, because if we're missing any terms, we're going to have to put zeros in their place to make my coefficients of like terms line up. Number 12, is this a candidate for synthetic division?
Yeah.
How do you know?
Because it's x minus 2.
It's not x squared minus 2. It's not 3x minus 2. It's plain old x plus or minus a constant. Since I'm dividing by x minus 2, what do I put in the box? A positive 2. And then, before I just start writing the coefficients of the dividend out beside that, I'm going to say, am I missing any terms here? What am I missing?
X cubed and x.
I have an x to the 4th, I have an x squared, but there needs to be an x cubed between them. And what's the only thing I can put in there that won't really change the problem? I could put 0x cubed. And I have x squared, and I have a constant, but I don't have a first degree term in the middle. So I'd have to put in a 0x. So the coefficients I need out beside this box are, what's the first coefficient? 1 and then 0, 1, 0, 2. Any questions? All right. Skip one line on your paper, draw you a long horizontal line. And always just bring that first coefficient straight down. After that, you start a process of multiply, add, till you run out of things to multiply and add. You multiply the 2 in the box by the 1 on the bottom row. 2 times 1 is 2. Put that under the next coefficient. And then add. Multiply what's in the box times what's on the bottom row. 2 times 2 is 4. Put that under the next coefficient. And then add. Y'all go ahead and finish that one. Finish the multiplying and adding. Is that what you got? All right, that's not my answer. That's the coefficients of my answer. If I'm dividing an x into an x to the 4th, what power is my first term going to be? An x cubed. So that 1 must be my coefficient of x cubed. That's x cubed. What would come after that? Plus 2x squared plus 5x plus 10. If that's my constant, I've run out of x's. What is that, 22?
Remainder.
It's my remainder. And you may remember in basic math, we could either write R2 to indicate the remainder is 2, or sometimes we wrote 12 divided by 5 is 2, and then we put the remainder back over the divisor. 12 fifths is the same as 2 and 2 fifths. We put that remainder back over the divisor. We can do the exact same thing in algebra. Put that remainder, 22, back over the divisor, x minus 2. The quotient is the whole number part of your answer. I wrote this out to the side because in the homework, my math lab gives you 2 boxes. It says put the quotient in this box and put the remainder in this box. So for the quotient, you would enter x cubed plus 2x squared plus 5x plus 10. And for the remainder, you would just enter the 22. Not 22 over x minus 2, but if I just say what is the remainder, the answer is 22. Any questions? For how many of you is this the first time you've seen synthetic division? I've never seen this before. Oh man, I'm only only sharing my excitement with one person. The rest of you are going, ooh, I've done this all my life. Aren't you excited though? That is pretty darn cool. Say yes when I ask you if you're excited. Say yes. All right. One more, just to make sure you have the hang of it. I'm going to be quiet and let you do it. As hard as it is for me to be quiet, I'm going to try. I give you one caution before you begin, and that's look for missing terms. Don't forget to look for missing terms. What did you get for a remainder?
0.
If your remainder is correct, then the rest of it's probably correct. I got a remainder of 0 as well. Now this problem actually asks us something else. Number 12 just asked us what's the quotient and what's the remainder, but number 22 says use synthetic division to determine whether x minus 2 is a factor of that. I just encountered a new word, factor. What does it mean in basic math if I say 3 is a factor of 15?
Can it fit into it each?
Divides into it evenly. There's something you multiply times 3 that gives you exactly 15, so it's a factor. Another way to say it is when I divide 15 by 3, I don't get a remainder. There's nothing left over, I get 0. Similarly, in algebra, if you do synthetic division with 4x squared minus 15x squared minus 4 divided by x minus 2, how can you tell if x minus 2 is a factor of that?
It doesn't have a remainder.
If it doesn't have a remainder. Do we have a remainder here? No, the remainder is 0. So the answer to the question, the only question my Labs Plus is going to ask you on this one is yes. When you say yes, make sure you know what you're saying yes to. Yes, x minus 2 is a factor of, not that a big ugly guy. In basic math, I can ask you, is 4 a factor of 24? And you divide and say, yeah, it goes in evenly, so it's a factor. That same thing. Is x minus 2 a factor of that other polynomial? Well, let me see. I divided. I got no remainder, so yes, it's a factor. Tonight's homework is the only time we're going to use synthetic division until we get to chapter 5. And so your wheels may be rusty by the time we get to chapter 5, and we'll have to do another example just to remember, oh yeah, that's what synthetic division is. But once you get your wheels going and you can do synthetic division again, you'll find out that it's very useful for other things. The other things are what we'll talk about in chapter 5. Tonight's homework is just learn to do synthetic division. And that's all that's in R.6. So far, so good. 2 sections down, 1 section to go. R.8 is rational exponents and radicals. What does the word rational mean in math? What's a rational number? Does it mean a sane number? A number that's not out of its mind? That's what it means in psychology. It means something different in math, though. What does it mean? A rational number is a number that can be written as a fraction. So 4 is a rational number. I can write it 4 over 1. 5 over 2 is a rational number. It's a fraction. 2.5 is a rational number. I can write it as 5 halves. Give me an example of something that's not a rational number then. Sounds like everything's rational. Pi, the most famous irrational, that just gave me chill bumps. I love math so much. Pi is the most famous irrational number. What fraction do we use to approximate pi sometimes? That's a decimal. You remember what fraction we use that's close to that 3.14? 22 over 7. We use 22 over 7 to approximate pi sometimes, but it's not exactly pi. Because pi is irrational, it can't be written exactly as a fraction. Rational numbers are numbers that can be written as fractions. So what we're dealing with here is fractional exponents. Ooh, just when you thought you couldn't have any more fun. We talked about positive exponents, we talked about zero exponents, we talked about negative exponents. But if you look back at last night's homework or R.2 homework, we didn't have any fractional exponents. So that's where we are, and we need 2 new definitions. The first definition, a to the 1 over n. Whenever I see a negative exponent, what R word pops in my head? Reciprocal. From now on, whenever I see a fractional exponent, I want the word radical to pop in your head, or root. Either one of those is okay. If you see a fractional exponent, I want you to think, I could write that as a root, or I could write that as a radical. Radicals are kind of a pain in the patootie to deal with. Those of you who have spent some time with radicals know, they can be a pain. So rational exponents were developed as a different way of writing radicals, so that we could just use all the rules we already know. We know rules for exponents. So if I could write that radical with an exponent, I could use all the rules I already know. Somebody worked on that project for a while and said, okay, let's write the nth root of a as a to the 1 over n. In other words, whatever the denominator of that fraction is the index of the radical when you write it in radical form. Now, in math, folks don't get to just make up stuff because they feel like it. It took a lot of proving to prove that this is going to work, but it works. So from now on, when I see 64 to the 1/2, when I see that rational exponent, I'm going to think, ooh, I could write that as a radical. What would that be if I wrote it with a radical?
Square root of 64.
When you write square root, you don't normally write the index. You don't write the little number right here that tells you what root you're taking. But if you don't write a number there, it's understood to be a what? 2. And so the index of that radical is the same as that denominator. And then the square root of 64 is 8. So that's what 64 to the 1/2 means. It's not half of 64, it's not 32. It's square root of 64, which is 8. What about negative 64 to the 1/2? If I wrote that with a radical, what would it be?
Square root of negative 64.
Square root of negative 64. Hey, think about yesterday or Monday. One of our biggest cautions from Monday was pay attention to the base. Without parentheses, the negative is not part of the base. If I had -5, that wasn't in parentheses, then squared. The negative's not being squared, just the 5 is. Is the negative part of the base in example 2?
Yeah.
Yes, so when I write it with a radical, it belongs under the radical. Now tell me what you know about square root of negative 64.
That's negative.
It doesn't exist in the realm of real numbers. When we get ready to leave the realm of real numbers, we'll have a name for it. But right now, I'm just going to say that's not a real number. Because there isn't a real number that you can multiply times itself and get a negative. You multiply a positive times itself, you get a what? Positive. If you multiply a negative by itself, you get a positive. So there's nothing, no real number you multiply by itself and get a negative, and that's why we're going to write not a real number. You may remember, this is just a prelude to what's coming. Does anybody remember from Algebra 2 or somewhere what we're going to use to stand for the square root of a negative? I. If you don't remember that, it's okay. We'll get to it in 2.3 or something. But right now, not a real number is good enough. What about number 3? Do I see that negative in parentheses and automatically go, hey, that's not a real number? No, I better be careful, because what does negative 64 to the 1/3 mean if you write it with a radical? Cube root of negative 64? Is there a real number that you can multiply times itself 3 times, since this is cube root, that will give you negative 64? Oh, well, you're right about the negative. Negative 4. Negative 4 times negative 4 is positive 16, but then 16 times another negative 4 will give you a negative. So that answer is negative 4, because if you raise negative 4 to the 3rd power, you do get back the negative 64. So all of a sudden I'm confused, and being stubborn and bullheaded, being confused makes me angry. So I'm angry, and I go into the learning center and say, how the crap is this possible? This is a real number, or this is not a real number, this is a real number, how the heck am I supposed to know? As a tutor, what would you say to me other than sit down and breathe? What would you say after that?
If you times a negative or a positive by 2, it's a positive. But if you times a negative by 3, then it's a negative.
Okay, that's pretty good. If I multiply a negative 2 times, I can't get a negative. But if I multiply a negative 3 times, I can get a negative. That's making me feel a little bit better, but then I'm wondering about, okay, what if it's not 2 or 3? What if it's 4? Can I take the 4th root of a negative?
If it's an even number, it's always positive.
That's the big picture. It's an even odd thing. If you multiply a negative an even number of times, there's an even number, you can pair those up. That will give you a positive, that will give you a positive, that will give you a positive. If you multiply an even, or a negative an even number of times, you're always going to get a positive. If you multiply a negative an odd number of times, you're always going to get a negative. So if you wanted to write me a note to calm me down, give me a pina colada, that would work too. You could write the note, even roots of negatives are not real numbers. Because you can't multiply a negative an even number of times to get a negative. Even roots of negatives aren't real numbers. Odd roots of negatives are real numbers. It makes me feel much better when I realize nobody's changing the rules every single problem, and I don't have to memorize crap that doesn't make sense. If I work on it hard enough, it'll make sense, and I don't just memorize it. I get it, and that's much better. All right, one more of those. Example 4. have a negative base to a negative exponent. Before I worry about radicals, how could I write that with a positive exponent? Take the reciprocal, I love it when you use the R word. Take the reciprocal of the base. Would that be positive or negative 64 in the base? Taking the reciprocal of the base makes the exponent positive. It doesn't change the sign of the base, it just makes the exponent positive. Does that make, you see the difference? Makes the exponent positive. So this is still negative 64, but now it's to the positive 1/3. That still is not technically correct, because why? Why is that?
Because the exponent is still a fraction.
That's why it's not finished, but that's not where the mistake is right here. If I don't keep that negative 64 in parentheses, I lost track of the fact it was part of the base here. It still has to be part of the base there. Good job. So, I wanted you to make sure you understood it. That still needs to be in parentheses. Now, if I write that as a radical, the numerator is still just 1, but I could write the denominator as what? With a radical.
Still cubed.
Cube root of negative 64. And what is the cube root of negative 64? Negative 4, so what's that answer in the simplest form possible? Negative 1/4. I'm just wondering about something else, because I had a pre-calculus student ask me this today, and I was thinking, well, if it bothers a pre-calculus student, it may bother a college algebra student. So the question in pre-cal this morning was, is that the same as that? Are those two things the same?
Yeah.
They're both negative 0.25. Is it the same as that? Punch it on the calculator, see what you get. 1 divided by negative 4. What is it? Anybody have it yet? It's still negative 0.25. This is negative, positive divided by a positive. This is negative 0.25. This is a negative divided by a positive is negative 0.25. This is a positive divided by a negative is negative 0.25. Those three things are the same. We don't normally write fractions like that. Math folks don't leave a negative in the denominator. We write it either like this or this. But I do want you to understand they're all the same thing. Is this the same thing? If you're writing this down, make sure you put a big old not equal to there. The moral of this story is, if you have a negative in front of a fraction, you can put it in the numerator, or if you feel like a rebel one day, you can put it in the denominator. You cannot put it in both, or it changes the value of the fraction. I'm going to come back to that sentence in R.7. That's going to be important when we start throwing letters in with our fractions. All right, so this first definition only applied when the numerator is 1, a to the 1 over n is the nth root of a. I got that. This is a to the something else over n. What if the numerator is not 1? Well, this definition says I can still take the nth root of a. The denominator still gives me the index of the radical, But after I take the nth root of a, I need to raise the whole thing to the nth power. Chew on that a minute. 4 to the 3 halves. What root is being indicated by that fraction?
Square.
The denominator says this is square root of 4. And this definition tells me after I take the square root of 4, I need to do what? Cube it. Raise it to the 3rd power. So I can do that. Square root of 4 is 2. Cubed is 8. 4 to the 3 halves is 8. Is anybody wondering, hey, is there a different way I can do that? Because usually somebody says, would it be the same thing if I did something, something? Is anything else occurring to you? Y'all just trust me, huh? Whatever I say. Now let me tell you something else. Somebody usually asks if it would be okay if I cubed the 4 first and then took the square root. Would it be okay if I had the 3 under the radical instead of outside the radical like I did here? Well, let's see if we get the same answer. 4 cubed is 64, and the square root of 64 is 8. So we do get the same answer either way. The answer is yes, you can either put the exponent under the radical or you can put it outside the radical. The reason I usually put it outside is, what if this was, say, 64 to the 3 halves? I'd have to be able to cube 64 in my head and then take the square root. I can't cube 64 in my head. So it's just simpler. I can do more problems in my head if I take the root first. I'll have a smaller number to cube or to raise to whatever exponent. It's not that it matters, it's just usually easier for me to take the root before applying the exponent. So 16 to the 3/4, what root does that indicate? 4th root of 16. Do you want to cube the 16 before you take the 4th root or after you take the 4th root? I can't cube 16 in my head. So I'd rather take the 4th root of 16 and then cube it. I can think of a little bitty number you multiply times itself 4 times. That would give you 16. It's got to be pretty small. It's 2. And then I cube it, and that happens to be 8 as well. What about number 70? How would you write that with a positive exponent? Luke, what do you say? 1 over 16 to the positive 3 halves. And let me tell you what you did really well, Luke. Every once in a while, I have folks get confused and start taking the reciprocal of the exponent. There's nothing in algebra that makes you take the reciprocal of the exponent. So I like that you knew it was positive 3 halves, not 2/3. You didn't flip the exponent, you just flipped the base. All right? So with a radical, what does 16 to the 3 halves mean? Square root of 16. And then what? After we do that, we'll cube it. So square root of 16 is 4, and 4 cubed is 64. You try number 74. When you took the reciprocal of 8 over 27, did anybody put 1 over 8 over 27? You could, because that's normally what we do if we have reciprocal of a whole number. You put the whole number under 1. But how do we divide a whole number by a fraction? Basic math. How do you divide a whole number by a fraction? You could. You don't have to, though. If I gave you the division problem, 1 divided by 8/27, you multiply by the reciprocal of the second, the divisor. And you just get 27 over 8. So there's no point in writing 1 over 8/27. 1 over 8/27 just flips it to 27 over 8. To write that with a positive exponent, all you have to do is write it as 27/8 to the positive 2/3. Go ahead and finish that one if you haven't. What root is being indicated there? Cube root. So I'm going to take the cube root of 27/8, and then I'm going to square it. And I absolutely love that no one has reached for a calculator. You don't have to have a calculator to take the cube root of 27 over 8. You just squint hard and say, what little number multiplied times itself 3 times would give me 27? 3. And what little number multiplied by itself 3 times would give me 8? So what's the cube root of 27/8? 3/2. And then I need to square it. You get 9/4. Any questions?
I did the problem a little bit differently,
Tell
but
me.
I came out with the same answer.
Tell me. I'm interested in knowing how you did it. Tell me what you did.
I first found the cube root of 8 and 27 just in the fraction how it was originally,
Okay.
and then I had 2/3 power of -2, and then I applied it to each one individually, and then I put the 3 on top, and the 2 on the bottom to make them positive, and then
I understood that. You did the same thing in a different order. I took care of my negative exponent first and my radicals at the end. You took care of your radicals first and the negative exponent at the end. Absolutely fine. Cool that you thought of a different way to do that. All right, these last 4 examples look like the 4 that we didn't get to Monday, the 4 that you may have had to watch on video. The only difference is, well, these are uglier because now not only are the fractions or the exponents, some of them negative, but they're negative fractions. That's just as bad as exponents can get. The whole reason for someone's development of rational exponents is because exponents are easier to work with than radicals. We already know our rules for exponents. If I wrote that, and don't write this down because I'm going to erase it after that, but if I wrote this problem with radicals, it would be the cube root of x and then squared And then the x to the 1/2 would be the square root of x. And x to the negative 1/4 would be 1 over the 4th root of x. That's what that problem would be if I wrote it with radicals. So do you want to learn how to work it with radicals? Or do you want to use the rules you already know and just work with those exponents? I'd rather work with this than this, even though they mean the same thing. I already know that when I multiply expressions with the same base, I just do what to their exponents? And I have a calculator with a fraction button, for Pete's sake. How easy can this be? That's x to the 2/3 plus 1/2 plus negative 1/4. If I can do fractions in my head, yay, I will. If I have to whip out my fraction button, okay, I will. But if I'm doing that in my head, the common denominator would be what?
6, no.
12. 12 is the smallest thing. 3, 2, and 4 will go into. So if I make all those fractions have the denominator 12, 2/3 is 8/12, 1/2 is 6/12, and 1/4 is 3/12. This is just if I'm trying to do it on paper. If someone has stolen my fraction button, then I'm going to have to remember how to get common denominators and then say 8 plus 6 is 14, 14 minus 3 is 11. That's x to the 11/12. I have a fraction button. I don't even have to find a common denominator. That is a whole lot easier than working with that. I don't even think I could do that problem unless I understood that I could write those with exponents and just add the exponents. Any questions about this? All right. This next example, if I had to do it with radicals, it would be terrible. But with my quotient rule, I know when I divide two expressions with the same base, what do I do with the exponents? Subtract the bottom exponent from the top exponent. Tell me what common mistake I'm making right here. You said subtract the bottom exponent from the top exponent, so I'm writing 1/5 minus 3/8. What's wrong with that? It's not minus 3/8, it's minus negative 3/8. So I either need to write it that way, or I need to go ahead and say that's 1/5 plus 3/8. If I have a fraction button, I just grab the calculator and punch 1/5 plus 3/8. If I don't, I get a common denominator, which would be what?
40.
40. And I write the 1/5 as 8/40. And I write the 3/8 as 15/40. And then 8/40 plus 15/40 is 23/40. Any questions? All right, two more. One that doesn't look too bad, and then number 86 looks like it was invented by the devil. 82, when you have a power to a power, what do you do with those exponents? You multiply. So yay, if I can do it in my head, I will. But for folks who need to see some steps written down, that's 4 times 3/4. And y to the 8 times 3/4. What's 4 times 3/4? Well, you can tell me without.
3/16.
No, because that 4 is over what? And then what? Oh, so the 4 is canceled? That's just x cubed. What about 8 times 3/4? Just 6. X cubed y to the 6. I just took a deep breath, approaching 86, and y'all was, I don't know, you're not paying attention to me when you're taking a test, because you're paying attention to the test, but if you're working on the test and I see you frown and little sweat beads pop out, I start trying to breathe for you. Like, oxygen to your brain. You can do this. Keep breathing. Number 86. I have hardly ugly fraction. Order of operations says do what you can in the numerator, do get what you can in the denominator, and then worry about putting them together. All right, so just looking in the numerator. If I cover up the denominator, I'm less scared to begin with. I have factors raised to a power. I just need to raise each factor to that power. What's the exponent of the 4, by the way? Inside the parentheses. It's 1. And I'm going to multiply the 3/2 by 1, just like I multiply the 3/2 times the -1 and the 3/2 times the 1/3. 3/2 times 1 is 3/2. 3/2 times -1 is what?
Negative.
-3/2. Y'all are bringing me. 3/2 times -1 is -3/2. What about the y's? 3/2 times 1/3 is 1/2. Very good. That's my numerator so far. Let's take one step in the denominator. What's that denominator going to be without parentheses?
Square root of xy.
You started making it harder when you changed it to radicals. You're absolutely right, but remember how hard it is to work with radicals? Let's just leave it exponents. How could I write that without parentheses? Absolutely. X to the 3/2, y to the 3/2. So far, so good. Breathe again. What does 4 to the 3/2 mean? A minute ago, somebody, when I said, what would this be without parentheses, somebody said square root of x, and I said, you probably don't want to go there because you can't take the square root of x. You don't know what x is. It's a good idea right here, though, because you know what the square root of 4 is. I would go ahead and think of that as square root of 4 is 2, and then 2 cubed is 8. I meant not to make that division sign so long. Play like I didn't. Just play like I wrote 8. And then let's deal with the x's. The quotient rule says when I divide two expressions with the same base, I subtract the bottom exponent from the top exponent. What's -3/2 minus 3/2? You can punch it on the calculator if you had to. Do they? -3/2? Here's the math problem I'm trying to do in my head. Does that give you 0? No, it gives you all right? Use your calculator if you need to, but you have to know what to punch on the calculator, and it's this, and it gives you -3. So x to the -3. Y to the, what am I punching on the calculator? 1/2 minus 3/2. 1/2 minus 3/2 is negative 2/2, better known as negative 1. If you leave that as an answer on the test, why are you going to get minus 2?
Because the negatives are still on top.
We don't leave negative exponents unless we have a number so tiny we're putting it in scientific notation. That's the only time we leave negative exponents. We don't need scientific notation. So how do you write that with positive exponents only?
8 over x to the 3rd power y.
Beautiful. So you get more practice with all the rules that you used in last night's homework. The product rule, the quotient rule, the power rule, the zero exponent, the negative exponent. But the additional twist that's thrown in tonight is some of the exponents for fractions. Any questions? All righty. Homework is assignment 2 in my math lab. And make sure you bring the R7 notes with you tomorrow. If you haven't already printed some notes, you need R7 tomorrow.